Thank you. Thank you. Thank you. Thank you. All right, let's start talking about some of these. I know that I gave you the solutions, but instead of just looking at the solutions are more for you to use as studying when you get home. Let's talk through these. Are there any questions about these four functions? These four graphs. Are there any questions that we want to ask about these four graphs? I need to work on explaining them. So one thing I want to point out here, number one, is it enough to say that this graph is concave down, so it's quadratic? No. Concave down is a description for what shape?
Quadratic.
The function is quadratic, the shape is parabola, right? So you cannot, to just say it's concave down is not enough justification to earn like a 6. You would have to say, hey, this is a concave down parabola. If you were to just say it's a parabola, that's probably a 5.5, or it's a quadratic function because it's a parabola. The full understanding, that complete understanding would be to say that it's a concave down parabola, so we know it's quadratic.
I thought the highest you could get was a 5.
6.
Dang, so 4.5 wasn't even good.
So I'll tell you this, I consider
4.5 good.
I consider a 4.5 a high enough score to count it as correct. Anywhere from a 4.5 up to a 6, I consider correct. You at least show me enough justification for me to think that you understand it pretty well. But a 6 is perfect. No one's going to average 6s. I've never had anyone average a 6.
I got a 6.
Huh?
Ain't nobody gonna get no 6.
I got a
Multiple
6.
people get 6s. I just said no one averages a 6.
You know what average means on one?
I know, algebra 2. All right, another quick detail I want to point out. I saw a lot of students on number 2 talk about it having a constant additive rate of change. Right now on number 2, do you know what that constant additive rate of change is?
No.
No. Can you find it though?
Yes.
Because what's the name for that constant additive rate of change? Slope. Now y'all need to be careful with identifying that slope, because if it's not perfectly on the intersection of the grid system, that's not a point you want. The next perfect intersection on the grid system is there. And then after that, it's here. You need to be careful, because that will mess up your slope, it'll mess up your equations. Now another thing is, I saw students doing this. And that's okay. But remember, you need to think about whether you're adding or subtracting. So what could I put to indicate whether I should add or subtract? Arrows. Because if it's going up, what's happening?
Adding.
Adding 3. And it's going to the right, so what's happening?
Adding.
4.
We don't know.
You can look at the paper. Okay? So yeah, adding 3 and adding 4. And we'll get into more of this later, but there's words that we want to use to describe here. Now, we'll also point out, I would not go left and then down, because you always want rise and then run. Now, you could have done something even like this and talked about the slope this way. So I think that's down 6, right? And to the left 8. Notice it does not matter. And so now I would say you could tell me, hey, this function has a constant additive rate of change of what?
Linear function.
Of what? 3 divided by 4 or 3/4. Either way is fine, right? Notice you need to tell me what that constant additive rate of change is if you're going to make that claim. Okay? 3 and 4, we'll look at these a little bit more in a second. But in order for you to claim that there's a constant multiplicative rate of change, you need to know what that constant multiplicative rate of change is. You can also just tell me it's exponential because the graph is an exponential curve. What word can you not use here that starts with an L? You cannot call this a line because it's not a line, it's a curve. All right? Any questions before we move forward?
Number 2.
Yeah.
I thought when you find like the slope, you had to get the points that was on each axis.
Yeah, you do not. That I could see why you think that, but no, you just need points that are intersecting on the grid perfectly. Because if you actually look at this, a lot of students, oh, first off, I do want to make this note. A lot of you are flipping your points. You gotta remember, it's an X and then a Y. It follows the alphabet, right? X comes before Y. So horizontal is our X-axis, vertical is our Y-axis. But if you look at that again, that is not a 5,0. It's like a 5.1 or so. We don't know exactly what it is, so we can't use that x-intercept. Does that make sense? So you don't have to use the intercepts, you just need to identify 2 solid points. Okay? You good with that? Okay. Now this next one. Woo-wee! 5 and 6, y'all kill me. First off, I need you to notice that you work from left to right. So you work from -3 to 1. And so I saw a lot of students doing +8 here, and then +4, and then +2. But is 16 + 8, 8? No, okay. So if you wanted to think about it, you could have done minus. But if you then look even at that, right, is that constant additive? No, so that should be a sign, okay, it's not what type of function? It's not linear, cool. To go from -8 to -4, guys, you have calculators, check yourself. That's +4, that's +2, that's +1. Okay, that's not constant additive either.
It's 102.
So, okay, first off, we're going to get to that in a second. But notice, it's not additive. You got to remember, what's the other thing we have other than additive rates of change? Multiplicative. If you don't have that additive rate of change, you need to pay attention to that. Then the next thing I saw was this. I saw a lot of division by 2. I mean, 16 divided by 2 is 8, is it not? 8 divided by 2 is 4, is it not? And that's constant. But what's the name for the exponent, or the rate of change for an exponential function? Constant factor, which is constant multiplicative, right? What's the issue?
That's division.
That's division. And that's okay, but if you're going to try to write an equation, you need the multiplicative rate of change. So, what's another way to write this? 1, what's this symbol? Division by? Notice how that is the multiplicative inverse, right? Dividing by 2 is the same thing as the reciprocal. You want that reciprocal, you want the multiplicative rate of change. It will make writing equations easier. Always look to write it as a fraction, that 1 divided by 2. You got to know that. Now, with number 6, the one thing I want to point out is I saw this a lot, which means that a lot of students did not read all the way through the chart or the table. What's the issue if you're putting times 2 all the way through?
12 times 2 ain't 21.
Yeah, 12 times 2, that is not 21, is it? 21 times 2, is that 33? No, check yourself, because early on you would have been correct, which means that you will probably look through here and then you just stop looking at the rest and you just assume. Don't assume stuff. If it's not constant multiplicative, we should start thinking about what? Maybe, but rate of change. Constant additive maybe? To go from 3 to 6, I'm adding 3. 6 to 12 plus 6. 12 to 21, and again, you have calculators, use them. That's plus 9. 21 to 33. Okay, that's not constant additive, so it's not exponential, it's not linear, so we should be thinking quadratic. If you get to here, you should not stop because you need to show me that this rate of change is what type of rate of change. Like if you're going to say this is quadratic,
It got a linear rate of change.
it needs to be a linear, not just linear, but a linear additive rate of change.
And it's added 3.
That rate of change is being added by 3 every time. Notice constant additive. And because that's constant additive, I know that the rate of change is linear additive. You need to be careful and pay attention to that.
I got them mixed up, quadratic and linear.
So we're going to learn from our mistakes and do better by the test, right?
The only reason why I remember is because I remember quadratic got 2 columns.
Two, they're called differences,
Yeah.
sets of differences. So that's good to notice. So make sure you're paying attention to those notes, you're improving your understanding, because remember, whatever you made on this is not your final grade. If you improve your understanding before the test, you grow and you get better and you earn a higher score. Okay? Now I want to pause, and I'm not going to spend long here. Pretty much everyone noticed this plus 4. So is my constant additive rate of change plus 4?
You got a plus 3 on the X.
I got plus 3 on the x. Remember, what's the constant additive rate of change called?
Change in Y.
That's how we calculate it. It's called
Slope.
slope, which is change in y.
Over change in X.
My constant additive rate of change is plus 4/3.
So we only find the rate of change for like the y, the linear, not for quadratic.
So, I told y'all before, because of the complexity with it, well, it needs to be constant additive on the left-hand side as well for a quadratic, but because of the complexity when it's not plus 1, I won't be giving you an exponential where it's not plus 1, but you should check that as well. Because it is possible that you get a table or a function that's neither of those. Okay?
I got a
So
question.
you gotta check that. Yes, ma'am.
It's about the ones on the bottom.
Yeah, what's up?
Okay, how you got H of X and K of X, that's just the same thing as F of X, they don't change anything?
It's just function notation.
That's why I got, that's
H
why-
of x, f of x, k of x. Remember what I am saying is that x is the which variable?
It's what's being multiplied,
It's what's being, it's called, it starts with an I.
inverse.
Not inverse, that's how you solve equations. It's what it is my input
Input.
or independent
And
variable.
the whole thing is output.
And then f of x or the h of x or the k of x, that's my output. Okay, so just function notation. Now, a lot of y'all told me number 11 was quadratic. But look what's happening between the 3/4 and the x. What's happening there?
It's being multiplied.
They're being multiplied. There's addition, and then there's a simple multiplication, because what is multiplication?
Repeat.
Repeated addition. This function has a constant additive rate of change. So it's linear. Just like when it's y equals mx plus b, that simple multiplication, just that one multiplication, it indicates that it's repeated, or there is a repeated addition. And you can even find the additive rate of change very easily. What's being added repeatedly here? Remember, multiplication is repeated addition. So it's -3 that's being repeatedly added. Remember that 7 is the y value of the y-intercept. Remember, that's just a single value. I'm not repeatedly adding that 7. I'm repeatedly adding that -3 because of that multiplication. Here, we're repeatedly adding 3/4. You need to pay attention to that. A lot of y'all told me 10 and 9 were the same. But look at those exponents again. Those exponents are very different. That variable of x in the exponent indicates that this is what type of function? Exponential, because again, notice here I'm starting at what value? 3. That is known as the, or that is telling me the y-intercept, the a. And then what's happening to that 3?
It's being multiplied by 2/3, which is being squared.
Is it being squared?
I mean, no, not squared, it's just the X.
It's raised to the x. X is a variable. And it's not just being multiplied by 2/3, it's being, starts with an R. Repeatedly.
Oh,
Remember, an exponent is repeated multiplication. So it's being repeatedly multiplied by 2/3. You gotta keep that in mind. Let's take 5 to 10 minutes to look at this understanding check. Hopefully we can move through this one a little bit quicker. But guys, y'all gotta know those equations. You gotta know the equation of a linear function. You gotta know the equation of an exponential function. And we're gonna have two we're gonna have an understanding check when it comes to quadratics, because how many quadratic equations are there? Not quadratic, there's only 3. What were the 3 quadratics?
Vertex,
Standard,
standard.
vertex, and factor.
Right, gotta know the 3, vertex, standard, and factored. And remember, I'm only gonna ask you to write vertex or factored. We'll get into some more of that today.
I got a
Let's
question.
work within our small groups, so let's just say 5 minutes, because I know some of us already got here, and then we'll come back as a whole class. And I'll come back there and check on you. What's up? I don't know, I'm gonna make it this
I
week.
got a 2.
But how you gonna do it? How you like,
Okay.
If it's been on understanding check, we're gonna be tested. If it's been tested, I'm gonna ask questions about it.
Alright.
Where's that? What's up? Huh? I will point out, this one, and that one were all, I think even that one was on here. Where's the other understanding check? Oh, this is it. Yeah, notice that function is this function. This one is, no. Well, so, pick this way, I should say. That one is this one.
I don't see that's not.
This one is that one. And this one is that one. It's very close to that one. I like it. That's the only one I'm doing. 1, 2, 3, we're all on here. I was just asking you to write the equations for the most part. Okay?
How will you get 4 if you're going up?
Cause when he's doing.
I mean, yeah, when you're going over 5 times.
You're not.
Why not?
Because I think you did this before. You're starting here, correct? That's not a that's not a clear point. That's a clear point.
So you can
Right, you have to go to where there's an intersection on the grid. So you went up 3.
No, I was like, so I just relate a little, like where the dots are, like what they were.
Yeah, a lot of students mess up there. Hopefully we know how to fix number 2 now.
Yes.
It looks like I got a 2 or 1.
Any questions before I go check on other groups?
No.
Yeah. Oh, you need the second understanding check? Hey, does anybody else need a copy of this second understanding
You should
check?
get off.
How about the one that answers you?
No, the blank one, because you didn't take it last week. Yeah. What's up?
I do have another question. I lied. Whenever you finish.
I didn't find it because I thought I didn't have to go down. I mean,
You have to go
I got it
from,
right on this.
basically think of your x, you always read a graph from left to right. So you start from the most negative to the most positive in the x, which means you're going from here to here. Okay?
that rock can you not divide?
You can, but remember what's the rate of change for an exponential? You need it as a multiplication. Remember, we actually just looked at it with this one. It wasn't times 2, it was times what on the, when we went over this on the board? 1/2.
Well, here you
Come on, Anna, we just went over that problem. You gotta write those notes down when I write up on the board. Okay? Now, I wanna point out, because I saw you doing this on these as well. You took this point, this x, and this y, right? But that's not an additive rate of change, that's a point. Where did your 4/3 go?
Yeah, but not by 2.
Right.
But I wrote them 2.
Don't you need the additive rate of change, the 4 and that 3 somehow? You need that in there.
Yeah, I had did.
Think about how we calculate m, talk about it in the group. What's up?
That's not the 0. It's with the 0 is
That's not sense.
What's down?
You can actually figure, you don't need that one, you can figure it out if you want it after you figure out what the rate of change through these are.
Right.
But try creating a table, right? That'd be 0, 2, 1, 6. You're trying to do slope. You don't need slope because it's not what type of function.
the rate of change is.
It's not linear.
Or, right.
So we don't want slope. Maybe make a table of those points, and from those points, you can figure out what the rate of change is.
Any way to exclusively show that that's what the rate of change is. 'Cause
Yep,
here
we're gonna
you
come
can
back,
mark
we're gonna start just, actually now,
Which
turn
that's
the
right,
equation.
that's the right consistency. But then you also have to.
Thank you, thank you, thank you. As a quick reminder, don't forget that part of your active collaboration also comes from asking questions. I'm not going to go into as much detail on these questions unless you ask questions. So, what questions do you want to ask about numbers 1 and 2?
I already had.
You already asked yours?
Okay, so for the rate of change
Yeah.
on the y value, it cannot be in any division.
Oh, so, technically it is division, but if you're going to write the equation, you want multiplication, right? And I will say, like, if you put the division by 2 here, as long as you recognize, like, for the last understanding check, you recognize, hey, that's a multiplicative rate of change, and you talk about it that way, you'll still earn higher scores on the rubric. But if you want to write an equation, remember it's repeated multiplication, so you need to think about it like that. And so that's why we want that times 1/2 here. Okay?
Can you write the,
Okay? So don't forget, and also I do want to point this out, in terms of justifying, first off, what would you need to talk about in number 2 to even get started on writing the equation? Anyone know?
the rate of change?
Okay, so the rate of change. So we would want to say what? Constant multiplicative rate of change. And notice I'm not just going to say that, I'm going to say what it's by what? 1/2. And so I want you to notice, so the function is, it's what? Exponential. I need you to notice, right, I made a claim. The function is exponential. You see how I gave evidence that there's a constant multiplicative rate of change? That's why I knew it was exponential. And now because it's exponential, what equation should I be using? Notice how I start at the basics. I define the type of function because the type of function tells me the equation. Now I can start to fill in these things as long as I know what these values are. This is exactly what I did when we first worked with these problems during class. You need to pay attention to the order of things because it helps. And I'm not just going to randomly plug things in. I'm going to explain what they are. Clear, consistent, and convincing evidence that you know what's happening. What was the A?
2.
2. And so, that's, why is it 2? That's the what?
Why is it so?
Very close. The y value
Of 0.
of, well, when the x is 0, right? Y-intercept. Or you could circle here and just say, hey, that's A. You're showing me that you understand it's the y value, the y-intercept. What do I mean by B? That's the what?
1/2.
The 1/2, which is the what for the function?
Rate of change.
Okay, what type of rate of change?
Constant. Multiplicative.
Constant multiplicative. Or you could also call it the constant factor. Remember, that's what it's called, constant factor. By showing me this, and I want you to understand, you don't have to do this every time, but if you want to earn a 6, this is what I'm looking for. Notice I am labeling my A, I'm labeling my B, I'm showing and explaining these things, and now y is equal to 2 times 1/2 raised to the x. Please notice that x did not become a square. I saw a whole bunch of you putting a square there, but a square is a quadratic function. It needs a variable of x in the exponent. Notice I'm labeling what these things mean. So if you saw me make a note of, hey, you need to know what the values of the equation are. Remember, x and y are variables. A and B are values. You need to tell me, hey, A is the y value, the y-intercept, B is the constant factor, things like that. Any other questions on numbers 1 and 2? But I want you to notice this model of how I make a claim and I show evidence for that claim.
It would have to be, 1/2, like the only other change that you can use.
What other rate of change would you be able to use?
Well, I did like, never mind.
But I think you did -8, -4, -2, right? But is that constant? No. You need to know what the rate of change is. We know it's times 1/2 because it's constant. That's what gives me the equation, right? The fact that it's exponential is how I got to that equation. So good question, but definitely learn from that. Any other questions on 1 and 2? 3 and 4.
Do 4.
Okay? What do you mean by do 4?
I don't understand how you got the algebraic factor.
So first off, I mean, here's the thing. We just talked about it. In order to know the equation, you have to know what? The type of function, right? So like you could have earned good points just from the beginning of telling me it's what type of function.
Exponential.
Number 4?
Oh, no,
You're looking at another thing. Number 4, it was exponential, right? Why do we know it's exponential?
Because they have an exponential
As an
curve.
exponential curve. Now the hard part, right? First off, as long as you know A is the y value of the y-intercept, it's really easy to get that 2 there, right? There's my A. Might be harder for you to find that rate of change. I saw a lot of students doing this. What are they talking about if they do that +4 and that +1? Rise divided by run, which is the
Linear.
what's the name of it? Slope, right? But that goes for a linear function, right? Remember, a slope is only a constant additive rate of change. Does this function have a constant additive rate of change? No. As a what? Constant factor. I want to remind you, do you have to keep this as a graph? What's another representation you could have created? A lot of us did that actually very successfully. If you need to find a rate of change, a table is a great way to go. Some of us tried to do the -1, but I will point out it's a little bit below that 1 there, so you don't want that. We don't know it yet, but 0, 2, 1 what?
4.
Not 4. Remember, it went up 4, so it would be 6. 2 what? 18. What's that rate of change? Times 3.
How did you get on it?
That's what I'm trying to see.
Y'all, it's the points right here.
Oh, I got, but for some odd reason I got 0 and 2.
0, 2. 1 and 6.
But I didn't do all that. I just put 0 and 2.
Yeah, because you found the y-intercept.
Oh, so it was.
Where you get 6 from?
Here's an x value of 1.
Erase them right.
1, 2, 3, 4, 5, 6. Right? Just look at that point. It is the point 1, 6.
When you put it on there, you start from the first point, like when you put on the little table thing, you always start from the first point, the top one.
Well, the one thing I will say is, how do you read a graph from left to right? So like, I put this x value at -1, but I don't exactly know that y value yet, so I didn't put the y value. But I knew 0, 2, and I knew 1, 6, and I knew 2, 18. So I will point out, I can actually figure it out now, 2/3 times 3 would be 2. So again, A, and what's B? What's that constant factor? Times 3. Remember, constant factor is my B.
I said 3.
Okay, I just didn't hear you clearly then. So 2 is A times 3 raised to the x. Remember, this equation's telling a story, meaning that I'm starting at what y value?
2.
2, and what's happening to that 2?
What's multiplying?
Not just multiplying,
3x.
not 3x. Remember, an exponent is not just multiplication, it is...
Constant.
No.
Constant factor.
It is a constant factor. What
Constant multiple-
operation is an exponent the same as? Repeated
Addition.
multiplication.
Oh.
Y'all gotta remember, a positive exponent is repeated multiplication. You gotta know that. Because that variable x is in the exponent, I know I'm repeatedly multiplying by 3. That's the story that this equation is telling. You gotta remember, simple multiplication is repeated addition. There we go, right? Y equals mx plus b. We got that addition and we got this simple multiplication. That's repeated addition. Raising to the exponent of x, that's repeated multiplication. That's where all this stuff is coming from. Any questions?
Yes.
What's your question?
Where did you get 2/3 from?
You didn't have to know it, but I knew that if it was 2, 6, 18, I'm multiplying by 3. And so I figured out that it's 2/3 because 2/3 times 3 is 2. I knew it had to be constant multiplicative. You didn't need this number.
Oh, okay.
You can't clearly see it in the graph,
Right.
but I knew it had to be times 3.
Okay.
Okay? Oh, it's way over there. Alright, nope, I need to go backwards. So you need your textbooks out, put your graphical, the understanding checks up, hold on to them, study them, figure out if you have more questions. One thing you can do is, you could rewrite those tables or redraw those graphs and work those problems out again, see if you know how to do them. Okay? I also have practice problems I can give you. I also sent you that email about stuff you can do on Khan Academy.
Do you have these papers, like extra papers? Or do you understand too?
Of the understanding check? No, not printed because I need to hold on to them for later classes, but I can make extra copies.
You want to make me one? Both understanding checks, maybe one?
Yes, somewhere. It's back there on that desk. I'll get it for you in a second and I'll put it up here. Okay, textbooks out.
You're not gonna answer my question.
What's your question?
I had said, could you print me one more?
I answered that.
No, you did.
Yes, I literally said right before Kelsey asked her question, not right now, but yes.
Okay.
Okay, objectives, right? We need to recognize each form of quadratic equation. We just spent a lot of time with linear and exponential. We now need to look at quadratics. We also need to identify the key features of quadratic functions revealed in each form. And now what we're going to focus on is using the features of a quadratic function in any representation to write the equation for that function. And so we looked at this last week, or Miss Courtney led y'all on this. Hey, we had a vertex, and we immediately, as soon as we know we have a vertex, what form of a quadratic should we be thinking about? Vertex form, right? But these two people got two different equations because they didn't know what A was, so they could choose any A they wanted. What we're working on today is writing the equation given an extra point, so we have to figure out what that A is. And so remember, here are work